Good morning, everyone. This is Thermodynamics lecture number 15. In the previous lecture, we have discussed conduction, and I think the previous one was dedicated to nodal theorem. I'm sure you have understood that. Have you tried any question on the nodal theorem? Have you tried to solve circuits using nodal theorem? Does it help?
Yes, sir. Tried, sir.
Were you able to solve them quicker?
Yes, sir.
Okay, that's the entire point of telling you that. And you must remember that whenever a question comes in JEE, and when I say JEE, I mean JEE Advanced, it will not be a straightforward question. And most of the question that you will encounter in circuits, you will find it very hard to do it with Kirchhoff's law. But if you understand the concept of nodal theorem, you should be able to solve them very quickly and very swiftly. Anyways, having said that, we'll move forward. I think there was one thing that was left in conduction, which I just came across. And so we will discuss it in brief. We will not be doing the entire derivation because that is already there in your notes. You have got those notes that I have sent you, the written notes. You have got them. Yes, no.
No, sir.
You have not received the written notes still of
No.
heat transfer. Did you get the notes of the previous one, the calorimetry wala chapter?
Yes, sir.
But for heat transfer, you have not received any notes.
Received, sir.
So why are you not telling me? Why are you telling me that you have not received it? You received the note for heat transfer, yes or no?
Yes, sir.
Okay, so what I'm gonna share is a part of that note only, because there is no point of me wasting any time in just deriving the entire thing when it is already there very nicely. And here it comes, and the heading is growth of ice on lakes. Have you gone through this? Have you seen this before? Growth of ice on lakes? Have you gone through this topic before?
No,
Yes or
sir.
no?
No, no.
No? Okay. So I'll just tell you in very short what happens. How does ice grow on lake? Does it freeze from top to bottom or bottom to top? Does a lake freeze top to bottom or bottom to top? Have you heard my question, bacha?
Once again, sir.
Does a lake freeze from top to bottom or does it freeze from bottom to top?
Top to bottom.
Why is that so? Why not from bottom to top? Do not know the answer? This is because of the anomalous expansion of water. Water has the highest density.
At -4 degrees Celsius.
Minus 4 degrees Celsius. Minus 4 degrees Celsius, it is not water, it is ice, bacha. At 4 degrees Celsius, the density is highest, and because of that, lake will always freeze from top to bottom, and as more and more ice gets deposited on the top of the lake, the rate at which the ice deposits will always slow down, because the only way the bottom wall of water can freeze is by conduction, and ice is a very bad conductor of heat. And hence, whatever happens, even in the great winters when the entire earth was all ice age we call it, even the entire earth was under ice age, lakes and oceans do not freeze completely because they freeze from top to bottom. In the bottom, it was always water, somewhere around 4 degrees Celsius, 5 degrees Celsius. As you go down, the temperature will increase further. And the aquatic life, the marine life was able to survive even the ice age. This is what you call God has made it like this, and that is why we survived. So what is happening is, if you can see the figure here, can you see this figure? This one? Do you see this figure? The diagram that I'm trying to show you, this diagram. So in this diagram, what has been shown is that on the top, you have atmosphere or air, which is at a temperature of minus theta degrees Celsius. It has to be less than 0. Then this ice starts to form from top to bottom because of anomalous expansion of water. At some point in time, the width, the thickness of the ice slab or the ice coating is y. In small time dt, this will change by dy. The layer which is just in contact with this ice is at 0 degrees Celsius, but the water below remains at 4 degrees Celsius because 4 degrees Celsius water is heavier than 0 degrees Celsius water. Do we understand this? Yes or no? Do we understand this? Yes or no?
Yes, yes.
Yes. So basically what we got to derive is the relation between how much, after how much time, what is the thickness of the ice, and we'll not go into derivation of this part. We'll just go through the formula, and the formula is there, but I'll just enhance it. And here comes the formula, and you will draw this diagram and keep this formula with you forever. The relation between time and the thickness y. After how much time the thickness becomes y. This is the formula. If initially the thickness is 0, how much time the thickness becomes y, and as you can see, it is proportional to y square, so it's a parabolic curve. Do we understand this?
Yes, sir.
If a question asks you to find out the time taken to change the thickness from y1 to y2, this is the formula straight away that you can apply. Now you must remember what means what in this formula. What does rho stand for in this formula? What does rho stand for? What does rho stand for? Rho stands for density. Rho stands for density of water or density of ice. Do we get this?
Yes, sir.
What does L stand for here?
Length.
L?
Length.
L stand for the latent heat of melting of ice or freezing of water. Water is going to freeze into ice, so L is the latent heat of melting. If you have a problem, you can write it as Lm, latent heat of melting. 2 is a number. What does K stand for here? Do not say spring constant. What does K stand for here? The name of the topic is conduction. So what does K stand for here, beta?
Conductivity.
Yeah, coefficient of thermal conductivity of ice, and you must remember that ice is a very, very bad conductor. So this K is very, very small. If this K is very, very small, the time will be very, very large, and that is how aquatic life gets rescued, and they can still survive even in freezing winters. What does theta stand for here?
Temperature. Heat.
Temperature of the air, which is just above the ice. That is what it stands for. Do not put the negative value, put the positive value. I hope you understand. It is minus 4 degrees Celsius. Do not put -4, put 4. Remember, do not put degree Celsius, but you have to put Kelvin. Do we understand this? This is the formula in SI units, not in CGS ones, right? You get this?
Yes.
What does Y stand for here?
Thickness.
Thickness of the ice sheet. And what does T stand for here?
Time.
T stands for how much time it takes to get the thickness to Y. And in the other formula, we have Y2 and Y1. Y2 is the final thickness and Y1 is the initial thickness. I'll give you a minute to note it down. Just note this down and the diagram. If any question ever comes, the answer is straight in front of your eyes. They might give you a curve. Which curve between Y and T represents the correct relation? How does the curve look like? Well, how will the curve look like between T and Y? How will the curve look like, bacha? Between T and Y, how will the curve look like? I hope you are noting it down, everyone. Yes or no?
Yes.
How will the curve look like? How will the curve look like? I told you, na, the curve will look like a
Rectangular hyperbola.
Rectangular hyperbola. No, the curve is not a rectangular hyperbola between T and Y. The curve is a parabola. T is Y square. So it's a parabola. We got this?
Yes.
We get this?
Yes.
Okay. Now there are some things that you must remember and you can just note them down. Keep them in your mind and that will help you in solving the question. Point number 1, take care and do not apply negative sign. I already told you the temperature in the formula, and also do not convert it into absolute scale. You can put it in degree Celsius because this theta is the difference in temperature between the inner boundary and the outer boundary. Whether you do it in degree Celsius or you do it in degree Kelvin, the point is it has to be the difference in temperature, because heat flows because of difference in temperature. The difference in temperature will always remain same. Do we understand this? So if outside it is 5 degree minus 5 degrees Celsius, inside it is 0 degrees Celsius, whether to convert both into degree Celsius or you keep both in absolute scale, the final answer remains same. Am I clear? Am I clear?
Yes. Yes.
Just now I told you that you have to convert into absolute scale.
Yes,
Even
sir.
I skipped that, even I missed that point, that is the difference in temperature. So either you convert it into absolute scale or Kelvin scale or just keep it in degree Celsius, does not matter, because this theta comes from the difference in temperature. So difference in temperature will remain same. Clear?
Yes.
Ice is a very poor conductor, therefore the rate of increase of thickness decreases with time. Remember this, because these small points can come as a multiple choice question. They will just give you this diagram and then ask you, then give you 4 options, which are the 4 options are correct. So you just have to mark them. Clear?
Here.
It follows from the above equation that the time taken to double, triple the thickness, again it comes from T is proportional to Y square. The time taken to double, triple, 1 square, 2 square, 3 square, T1 is to T2 is to T is 1 is to 4 is to 9. Got it? These are the questions that will come, beta. And in the examination hall, you might not have time to do it. If you know it beforehand, you will be in a better position to solve this question. The time intervals changing from 0 to Y, from Y to 2Y, and so on. So basically they just put the value different Y's. So T1, time taken from 0 to Y, time taken from Y to 2Y, time taken from 2Y to 3Y, it will be in the ratio of 1 is to 3 is to 5. Do we get this? We can keep these things in our mind, because these questions will come and then we should not be in a fix. Just to make up this point and this question clear, I'll just give you one small question. I hope you can remember the formula and solve it, and the questions comes right away. So just give me the answer for this one. There is ice formation in a tank of water of thickness. So the thickness of ice is 10 centimeters. How much time will it take to have a layer of 0.1 centimeter below it? The outer temperature is -5 degrees Celsius. Thermal conductivity is given. Latent heat is given. Density of ice is 0.91 gram per cubic centimeters. Can I expect an answer from this? It's just about calculating. I understand that the what calculation may be a tad tougher, but I hope that you should be able to do this. Yes or no?
Yes.
Well, your time starts now, and I'll give you a minute to win it. You just need to put the values in the formula, and you are done. Do you remember the formula, bacha? Do you remember the formula, beta? Are we trying? Anyone there? Are you trying the question, or shall I go ahead with the solution? Okay. So, how do we solve it? We just put the values of the quantities in the equation, and we end up with the answer. We are asked how much time it takes to convert the thickness or increase the thickness by 0.1 centimeters. Time, as you know, is rho L by 2k theta into y2 square minus y1 square. Rho is given as 0.91, everything in CGS unit. So we'll just put it 0.91. L is given as 80. Remember, if this question comes in JEE, the values may be given in joules. Doesn't matter. Difference in temperature always remains same. 2 divided by k. K is given as 0.005 multiplied by theta, outside temperature -5. We just have to look at the difference, that is 5, multiplied by the final thickness is 10.1 and the initial thickness is 10. So 10.1 square minus 10 square, and you get the answer. Remember, the answer will come in seconds. That is converted into minutes, and we have 48.77 minutes as the answer. Do we understand this?
Yes, sir.
Everyone understand this?
Yes, sir.
Well done. Then that will take us to the next heading. We are done with what? We are done with conduction, and now we will move ahead with the next mode of heat transfer. And what is the next mode of heat transfer? The next mode of heat transfer is convection. Remember, what do you say? A numerical on convection may not be there in your JEE because this is not a part of your JEE curriculum. But again, they can give you a paragraph and they can give you a question. And remember, the formula that comes here is exactly similar to something that you already know. Convection. So in convection, what happens? This is the mode of heat transfer that takes place basically in where? Convection is a mode of heat transfer. Do convection take place in solids? No, it's a mode of heat transfer in solids as well, but the actual transfer of atoms from one point to other is basically not possible because they are very closely held together. So it may not be the major component in solid for heat transfer, but it is the basic mode of heat transfer in where? I've already told you, right? Do you remember it? Convection takes place in what type of bodies, what type of substances? Do we remember this? Do we remember this, beta? Is there anyone in the class?
Yes, sir.
Where does convection take place? Don't know? It is a mode of heat transfer that takes place in fluids. When I say fluids, I mean liquids and gases. Will you remember it now?
Yes, sir.
Okay, thank God. It takes place in fluids. And how does it take place? In conduction, there was no actual movement of atoms from one end to the other end, one from the heated end to the colder end. Atoms were not getting transferred, they were vibrating and they were transferring energies. But here, what happens is there is an actual migration of particles. So, this mode of heat transfer takes place by the actual movement of particles. Particles are actually moving. Now, see, here there is a beaker. And we are heating water in the beaker. The heater is here. Now, how does the water get heated up? First of all, the heat will heat up the lower portion of the beaker. Then by conduction, that heat, because solid is conduction, by conduction that heat will pass onto the lowest portion of the liquid. Obviously, the liquid will also get heated up from its sides, but only the outer surface will get heated up because of sides, and the lower surface will get heated up because of heat coming from the lower side. Do we understand this?
Yes, sir.
Now, when the lowest most layer gets heated up, the temperature increases, its density decreases. So what will happen? This lower layer which is heated up will come where? Will come, the density is less. The water which is above it is colder, density is more. The water on the lowermost layer is heated up, density is less. What will happen now? Do we know what is density, beta? The water on the upper side is more dense and the water on the lower layer is less dense. So what will happen, beta? No idea? The less dense water, which has got less density, will come up and the heavier water will settle down. Yes or no? Is there anyone in the class, beta? I can't see you, so I don't know whether you are there or not. Are we there in the class? The mic, is the mic not working? becomes very difficult for me to communicate this way. Is the mic not working? Okay. So without mic, I'll have to continue. Don't worry. So the water at the lowest point is now heated up. The density is less. So that water will move up and the upperwala water will come down. When the upperwala water comes down, it will again get heated up. The lowest portion will get heated up. Heated water will go up. Colder water will come down, and hence there is an actual transfer of the materials, of the particles, and this mode of heat transfer is known as convection. What is the reason for convection? They might ask you, what is the reason of convection? So you can call them as two reasons. This arises due to the difference of densities at two places. When the density is different at two places, hot air balloon, it goes up in air. Why does it go up in air? Because hotter air is less dense than colder air, and therefore this hotter air will take it upwards. Convection, sort of convection. So if there is a difference in density between two places, and because of gravity of earth, if something is less dense, that means it has less mass for the same volume, it will be attracted less towards earth. Heavier object will get attracted more towards earth. So there are two reasons why this convection happens. One is because of difference in densities, the other is because of gravity. Because of gravity, heavier things will come down, lighter things will go up, and that is what is known as convection. So remember this two reasons. They can ask you in multiple choice question: because of difference in densities, because of gravity. If it happens naturally, as in the case of heating water, this is known as natural convection. Nothing is forcing it. It's happening naturally. Land breeze, sea breeze, they happen naturally. No one forces them. But then there is another type of convection which is known as forced convection. In this forced convection, we force the heat or the particles to move. You might see in a bhatti, an oven, a bhatti in which that tandoori roti is cooked. That bhatti, and you have this small pipe through which you blow air, you blow hot air out inside. Forced convection. You have, it's summertime, you will have your AC. The AC has colder air. Now this colder air is thrown out of this AC, thrown out of this AC. That is also forced convection, because I'm forcing something out. Then after that, what happens? The colder air will come down, the hotter air will go up, and therefore you always put AC on the top, the split AC on the top. Why do you put split AC on the top? Because the hotter air will go up, and that air should go inside the AC, and then AC, forced convection, will force it out, the colder air. The colder air will already settle down, and the hotter air will always go up. Do we understand this? This is forced convection. Natural convection happens naturally. Forced convection happens because we are forcing something out. You just need to know the principle. Even if this is not a topic, a numerical is not expected, but theory is always expected. So you can expect that a theory might come. Now, as far as the numerical is concerned, the numerical can be in this form. So you should remember this form because it looks similar to something that you already know. Now, by convection, this is not in your topic, this is not in your course, but remember this because this formula is already there. In Newton's laws of cooling. So that is why the rate at which a body loses heat due to moving fluid is directly proportional to the surface area, and it is proportional to the difference in temperature. So you can write Q by T or delta Q by delta T, rate at which this convectional current is flowing or the heat is getting transferred will be equal to H into A into the difference in temperature. Remember here, A is the surface area of the body. That means more the surface area, ocean surface area is huge, and that is why you have huge land and sea breezes. T is the temperature of the body. T naught is the temperature of surrounding. It only happens because of difference in temperatures, because difference in temperature creates difference in densities. And H, this H is a constant of proportionality, and it is known as the convection coefficient. Will you remember this? Can I have some reason that we understand this? This formula is exactly similar to what we'll come across in Newton's laws of cooling, and that is why this question can come. Obviously, if it comes, it will not come in JEE Mains, it will come in JEE Advanced. And since students don't know what is the formula for convection current, they will give you this formula. They'll give you this formula, and then they might ask you a couple of questions, 3 marks each, 2 marks each. You can score 6 or 8 marks, and it will be for free. Most of the students who will see this question, oh, it is on convection, we don't know convection, they might skip it. But at the end of the day, you realize that this is the simplest question in the entire paper probably. Remember, whenever the comprehension is given, that is probably the simplest question. And if the comprehension is based on a topic which is not there in JEE course, it is the simplest of all. Take my words for it, you can write it down. So this is how the convection formula looks like. H is the coefficient of convection. You can call it convection coefficient. This is how the formula looks like. You can always have a different variation of the same formula, where instead of the thermal current or the rate at which it is flowing, you may be interested to know how the temperature of the body is changing. Now, to have that formula, again, that formula is same as Newton laws of cooling. In Newton laws of cooling, we have the rate of change of temperature, right? We don't have the rate at which heat flows. But if we had a formula for Newton laws, in heat flow, the formula will look like this. I'll tell you that formula as well. Now, in Newton laws of cooling, we have the formula for rate of change of temperature. Here also, we have the formula for rate of change of temperature. And the rate of change of temperature formula, if I write it as d theta by dt, the rate at which the temperature of the body is changing, because I don't want to write T for temperature and T also for time. That's why I'm using theta. D theta by dt will be equal to minus K2, another constant. Now, in Newton laws of cooling, the constant is different. We come to Newton laws of cooling, don't worry. In convection, the coefficient is different, multiplied by d theta, where d theta is the difference. The negative sign indicates that when the difference in temperature is less, the rate at which heat transferred is less. Now, this K2 constant and this H1 H constant are related to each other, and it is not very difficult to understand that this constant will be equal to H into A divided by M into S. I hope, instead of S, since S might look a bit different, I will write it as M into C. H standing for the convection coefficient, A standing for the area of the body, M standing for the mass of the body, and C standing for the specific heat of the body. Do we understand this? Can I have some reason that we understand this? This is how the formula for convection will look like. I'll give you a minute to note it down. Okay, if you have done this, we will move forward and note some important points again. Theoretical questions can definitely come. What all factors on which H depends on? So H depends on the properties of the fluid. It depends on the density, it depends on the viscosity, it depends on the specific heat and the thermal conductivity of the body. Natural convection takes place from bottom to top. Why it takes place from bottom to top? Bottom, it is lighter air. If the hotter air is there, hotter air can always move up, hotter air cannot move down. Colder air can always move down, colder air will not move up. So natural convection takes place from bottom to top. Why is the forced convection can take place in any direction? If I have an AC and if I put the fan of the AC like this, it will start throwing up air, colder air on the top. Why? Because it is forced convection. I am forcing it out. In case of natural convection, convection moves warm current upwards and cool air downwards. We know this. Natural convection plays an important role in ventilation, in changing the climate and weather, and in forming land and sea breezes. Natural convection is not possible in a gravity-free region. Remember, in space, convection is not possible. Two reasons for it. In space, first of all, there is no medium. There is no fluid that can flow. Even if there was fluid, but there is no gravity. There is no gravity, convection cannot take place. So if on Earth we create a vacuum chamber and then we expect convection to happen, convection will not happen. The force of blood in our body by heart keeps the temperature of the body constant. If liquids and gases are heated from top, why don't I heat it from the top? Convection will not happen. The only way liquids get heated up is by convection. So when you heat it from bottom, then only hotter water will go up and colder water will go down. If you heat it from the top, if you had to heat it from the top, the upper wala layer will get heated up, but it will not go down because it is lighter. So nothing will happen. Only the upper wala layer will be hot and nothing else. Do we understand this? Can I have some raise hand if we understand this? I hope you understand this. Remember, one more thing that now this thing can come in your JEE Mains. Mercury is a liquid. Mercury is an exception. It gets heated by conduction, but not by convection. So remember this. For Mercury, the exception is there. You all understand this? That was all about convection that you will ever need to know in this class or any class there in none. Maybe if you are doing some PhD work and heat transfer, probably you will need to know more about convection. Now, the time, my dear friends, that we move on to the next topic of this chapter. Mode of heat transfer is the name of the chapter, and the next topic is radiation. Have you any idea about radiation? Anyone, bacha? Do you know what is radiation? What is radiation? Now, there are different ways in which you can define radiation. Radiation is transfer of heat, but the name of the chapter is transfer of heat. So radiation is definitely transfer of heat, but you cannot define radiation by the transfer of heat. How does the transfer of heat take place in radiation? If you are talking about that point, well, yes. The mode of heat transfer, the mode in which, the process by which the heat gets transferred through solid in conduction or through fluids in convection and in radiation, all the three processes are different. I hope you have understood. In conduction, basically in solids. Convection, basically in solids, conduction happens. Conduction also happens in liquids and gases, but it is very small. Molecules, atoms vibrate with higher energy on the hotter end. They will transfer the energy to the nearby atoms, and the heat gets transferred from the hotter end to the colder end. But remember, when the heat is getting transferred from the hotter end to the colder end, the intervening medium, the entire solid body is getting heated up. So if this is the point where I've kept it in contact with a hot body, if this is the point where I have kept it in contact with a hot body, this is the point where I kept it in contact with a colder body, heat will flow from the hotter end to the colder end, but the intervening medium, which is the solid, will get heated up. Yes or no? Will get heated up? Yes or no? Yes, it does. It will not happen that this will remain hot, this will remain cold, and the entire thing will remain at some other temperature. No, the entire medium gets heated up. Similarly, in convection, this is a beaker that I have, and I heat it up. The entire liquid gets heated up. The entire medium gets heated up. Yes or no? Do we understand this? Do we understand this? So, in conduction or convection, the entire medium gets heated up. But there is a process, radiation, in which the intervening medium may not get heated up. May not get heated up. And it also does not require any medium as such, it may not require any medium. This mode of heat transfer, which does not require any medium, in which there is no heating of the intervening medium is required or done, this mode of heat transfer is known as radiation. And in this mode of heat transfer, the energy is transferred in the form of electromagnetic wave. It is the mode of heat transfer. By this mode of heat transfer, solid can transmit heat. Liquids can transmit heat. Gases can transmit heat. Does not require any material medium. It does not require any medium. It does not require the transfer of particles. Heat will get transferred. This mode of heat transfer is known as radiation. In this mode of heat transfer, the energy is transferred. Heat is energy. Energy is transferred in the form of electromagnetic waves or electromagnetic radiation. That is known as the process of radiation. Do we understand this? Any one of us understand this? Can I have some raise hand that we understand this? Okay. Now, whenever I use the term radiation, bacha, now this term radiation, you must remember that this term radiation is multi-meaning. It has a lot of meanings. When I say it has a lot of meanings, what do I mean? So when I write the term radiation, I might refer to a lot many things. Now radiation, the term radiation, multi-meaning term, it refers to the process. It refers to the process by which heat energy, if I write delta Q, is emitted by a body. The process which is making this body to emit heat. For example, if this was a hot cup of coffee or ice, coffee or tea, not ice. After some time, it will get cooled down. It has transferred its energy. That energy has gone in the form of radiation. The mode of heat transfer is radiation. Or if this was a bottle of cold drink, a chilled bottle of cold drink, after some time, it will come back to the room temperature. It has transferred its heat, or heat has transferred to this body. The process by which this heat has been transferred between the body and the surrounding, or surrounding and the body, the process by which this happens is known as radiation. Do we understand this? So this is point number A. Radiation refers to the process by which this heat energy is emitted. Do we understand this? Can I have some raise hand if we understand this? Yes, sir. Now, B. Now, when this energy is emitted, it does not require medium. Okay, we understand this. On Earth, we have medium, we have atmosphere, so it will travel through atmosphere also. In space, there is no medium, but the energy emitted by sun also comes to us by the process of radiation. We feel the heat of sun. There is no medium in between. It comes to us. The heat gets, the radiation, instead of calling it heat, the heat gets transferred through any medium or through vacuum by some process. That process by which this energy is transferred is also known as radiation. So it also refers to the process. Please mark my word so that you understand the word. It also refers to the process by which this energy is transferred. So when the energy is emitted, the process is radiation. When the energy is transferred, the process is also radiation. Point C, the energy itself is known as radiation. The name of the heat energy is also radiation. So radiation is a multi-meaning term. This is a chilled water of cold drink. After some time, it will come to room temperature. It has gained energy. The energy it has gained, you can call it radiation. The process by which that energy has been transferred to this body is known as radiation. The process by which this energy is accepted by this body is also known as radiation. So when I say this body is radiating energy, I refer to all the three terms. I refer to the energy itself. I refer to the process by which this energy is emitted. I also refer to the process by which this energy is transmitted. So when I say radiation, it's like Om, it means everything. Everything in the universe. I say radiation, I mean everything about this energy. Do we understand this? Can I have some reason that we understand this? Right. Now, what you must remember about this radiation, number one, it is in the form of electromagnetic waves. Do we understand this? It is in the, this energy or this radiation is emitted in the form of electromagnetic waves. Yes or no? It does not require any medium. Don't read medium for this. Yes or no? We understand this, everyone. It travels by the speed of light. Light is also an electromagnetic radiation. So any electromagnetic wave, a wave has energy. You can also call it radiation. Do we get this? It has all the properties of light or electromagnetic wave. So it has got the property of EM waves. So the topic of EM waves and the topic of radiations are same. That's how you relate things. Everything that you have learned about light is here. Same. Light is also energy. It's also radiation. Do we understand this? All bodies radiate heat or emit heat. All bodies radiate or emit heat by this process, whether it's a solid body, whether it's earth, whether it's a liquid, this, that, falana, dimaka, all bodies will emit radiations. We'll come to that theory as well. All bodies emit radiation whose temperature is greater than 0 Kelvin. At 0 Kelvin, what happens? We don't know. We have not reached 0 Kelvin. So we have no idea what happens at 0 Kelvin. But if any body is above 0 Kelvin, it has to emit radiation. Some people may call it thermal radiation. Some people may call it heat energy. Some people may call it light energy. But it has to emit radiations, thermal radiations. Do we understand this? Can I have some raise hand that we understand this? Radiation, this is the introduction of radiation, and then we come to the most revolutionary theory of radiation. The most revolutionary theory of radiation. Do you know about the most simple and the most revolutionary theory of radiation? And that is known as Prevost Theory of radiation. Have you heard about this term? If you understand this, things become very simple. Prevost Theory of radiation. Have you heard about this term? No? Well, not a problem. Prevost theory of exchange is very simple. We have already seen that all bodies which are greater than 0 Kelvin emits radiations. We have already seen that. Yes or no? This body is definitely above 0 Kelvin. It is emitting radiations. But, and a big but, it is also absorbing the radiations emitted by different bodies which are around it, which are surrounding it. So example, if I say these are two bodies, my pen, revolutionary pen, and this revolutionary bottle, these are two bodies, and these are the only two bodies in the entire universe. This body is greater than 0 Kelvin. So it is emitting radiation. This body is greater than 0 Kelvin. It is emitting radiation. This body is more than 0 Kelvin. It is emitting radiations. Both the bodies are emitting radiation. But, big but, this is emitting radiation, this is emitting radiation. Now, whatever radiation this is emitting, this body, if they are close enough, obviously, whatever radiation this body is emitting, this body is going to absorb it. Yes or no? Since everybody emits radiation, it also has the right to absorb radiation which are emitted by the nearing bodies. Yes or no? So they don't only emit. They not only emit, but they also what? They also what? They also what? Tell me. A body is emitting radiation, but at the same time, it is also absorbing radiations emitted by nearby bodies. So all bodies greater than 0 Kelvin emit radiation and absorb radiations emitted by neighboring bodies. Now, this is a hot cup of tea. A hot cup of tea gets colder. If this is, it does not look like one. If this is a chilled, okay, if this is a chilled jar of ice, it will get hotter. Tea gets colder. This gets hotter. How do I explain it? One gets hotter. I lost my pen, so I just okay. Where is my chair? One gets hotter. Tea gets colder, and this jar gets hotter. How do I explain this? If a body emits more than it absorbs, then what will happen? I'm a hot cup of tea. I'm emitting more, but absorbing less. So what will happen? If I emit more, I will lose a lot of internal energy. And internal energy is related to temperature. If I emit more than I absorb, then what will happen? The temperature of the body will fall down or up? Down or up? I'm emitting more. I'm receiving less. Temperature will go down. Yes or no? Temperature goes down. If I emit less than I absorb more basically, then the temperature has to go up. Chilled bottle of cold drink emits less. It emits, but it emits less. Absorbs more. Internal energy increases. Temperature increases. If the rate at which the body emits is equal to the rate at which the body absorbs, the temperature remains constant. Do we understand this? And this is what radiation is all about. And this theory is known as the Prevost, a very, very beautiful theory which is explaining a very complicated thing in a very, very simple way. If you emit more, absorb less, temperature will decrease. If you emit less, absorb more, temperature will increase. At the same rate, temperature remains constant. So when this cold, chilled bottle of cold drink, it emits less, absorbs more, temperature keeps on increasing. Temperature keeps on increasing. When the temperature increases, it emits more, but again it is absorbing much more. So temperature will keep on going up. At one point in time, it will emit and absorb at the same rate. And that is why, my dear friends, this will come to the room temperature. When it comes to the room temperature, it is emitting and absorbing at the same rate. Do we understand this? That's it from my end for today. Prevost theory of exchange, which tells us how beautifully nature is made and how temperature increases, temperature decreases just by looking at objects. Emitting more, temperature will come down. Emitting less, temperature will go up. Room temperature, everything remains same. We'll start with the numerical part of this chapter in the next class. Till then, please go through this. If you have any doubts, you can always come up to me. For today, the class is over. Take care. Have a nice day.